Hello students, my name is G. Nikita, M. Pharmacy, Assistant Professor in the Department of Pharmaceutical Chemistry. I will deal the Medicinal Chemistry 2 subject for B Pharmacy third year's first semester. So today we are going to discuss about corticosteroids topic. It is the fourth unit. So in this we will discuss the introduction, types of corticosteroids, biosynthesis of corticosteroids, its biological effects, uses, and what are the classification, synthesis. So let's discuss about what is the corticosteroids introduction. So the adrenal glands are the triangular and highly vascularized gland located on each kidney. So this adrenal glands are located on the each kidney. So each adrenal gland is structurally and functionally divided into two regions, that is outer adrenal cortex and inner adrenal medulla. So this adrenal gland is divided into two regions, that is outer adrenal cortex and inner adrenal medulla. So again, this adrenal cortex is divided into three zones, that is zona glomerulosa and zona fasciculata and zona reticularis. So it is three zones, that is zona glomerulosa and zona fasciculata and zona reticularis. So these are the three zones which are present in adrenal cortex. And the corticosteroids are the steroid hormones which is secreted by the adrenal cortex. So this corticosteroids has been secreted by the adrenal cortex. So these hormones are essential for the survival as they concerned with the maintenance of the water and electrolyte balance. So this corticosteroids is very useful for balancing the water and electrolyte in our body and cardiovascular, energy substrate balance and functional status of the nervous system and skeletal muscle. For all this purpose like maintenance of the water and electrolyte balance and cardiovascular, energy substrate balance and functional status of the nervous system and skeletal muscle. For all these functions, this corticosteroids is required for our body. So corticosteroids basically are of three types. Let's see what are the types. So first one is glucocorticoid, next one mineralocorticoid, next sex hormone. So these are the three types. First one is glucocorticoid, next one is mineralocorticoid, and next one is sex hormones. So if you see the first one, that is glucocorticoid, which is secreted by the zona fasciculate of adrenal cortex. So this zona fasciculate is one of the part in the adrenal cortex. There the glucocorticoids has been secreted. So they are concerned with the carbohydrates, proteins and fat metabolism. So these glucocorticoids are involved in the carbohydrates, proteins and fat metabolism. So here cortisol and corticosterone are the two major glucocorticoids. What are they? Cortisol and corticosterone. This comes under glucocorticoids. They have carbohydrate storing, anti-inflammatory, anti-allergic and anti-cotropic properties. So this anti-inflammatory, anti-allergic, anti-cotropic properties have for glucocorticoids. So glucocorticoids are mainly secreted by the zona fasciculate of the adrenal cortex. So they mainly involved in the metabolism of the fat, proteins and carbohydrates. So here cortisol and corticosterone are the two major types which are involved in the glucocorticoids. So they have the anti-inflammatory, anti-allergic, and anti-corticotropic properties. So this is about the glucocorticoids. Next, mineralocorticoids, which has been secreted by the zona glomerulosa of adrenal cortex. So this is also one part of the adrenal cortex, that is zona glomerulosa. So they include aldosterone and deoxycortisone. So these two are involved in the mineralocorticoids, that is aldosterone and deoxycortisone. So they are mainly involved in the potassium, sodium and fluid balance. So this is mainly used for the balancing of the sodium and the potassium in our body. Next, sex hormones. So male sex hormones are released by the zona reticularis of adrenal cortex. So these are released in small amounts and are weak in action. So these are the three types of the corticosteroids. Next one is biosynthesis of corticosteroids. So adrenocorticosteroids are of 21 carbon compounds containing of cyclopentanol per hydrophenanthrene ring. So it contains this structure contains the cyclopentanol per hydrophenanthrene ring. So this has been synthesized in the adrenal cortical cell under the influence of ACTH from cholesterol. So this adrenocorticosteroids has been synthesized from the cholesterol under the influence of the ACTH, and it contains the 21 carbon compounds. So in this structure it has the cyclopentanol per hydrophenanthrene ring. So this is the biosynthesis of the uh, corticosteroids. So the starting material is cholesterol. So from the cholesterol we will get the pregnenolone, and from the pregnenolone it is divided into two, that is progesterone and 17 alpha hydropregnenolone. So this progesterone again it is converted to 11 desoxycorticosterone, and this 11 desoxycorticosterone is converted into corticosterone. This corticosterone is converted into aldosterone. So this comes under the mineralocorticoids. That is from progesterone to conversion of the progesterone to aldosterone process comes under the mineralocorticoids. Next here 17 alpha hydroxypregnenolone is converted into 17 alpha hydroprogesterone, and also from the progesterone also it is converted into 17 alpha hydroxyprogesterone. So this 17 alpha hydroxyprogesterone is converted into 11 deoxyhydrocortisone. From 11 deoxyhydrocortisone it is converted to hydroxycortisone, and this is reversibly converted to cortisone. So this 17 hydroxypregnenolone is converted to dehydroepiandrosterone, and this is converted to aldostenedione. So from 17 progesterone is also converted to aldostenedione, and this is converted into the testosterone. So this is the biosynthesis of the corticosteroids. So I will repeat it again. So when the cholesterol is converted to pregnenolone, and this pregnenolone is divided into two, that is progesterone and 17 alpha hydroxypregnenolone. So this progesterone is converted into 11 desoxycorticosterone and also 17 alpha hydroxyprogesterone, and this 11 desoxycorticosterone is converted into corticosterone, and this corticosterone is converted into aldosterone. Here the 17 alpha hydroxypregnenolone is converted into 17 alpha hydroxyprogesterone, This converted into 11 hydroxyhydrocortisone, and hydroxycortisone is converted to cortisone. So here 17 alpha hydroxypregnenolone is converted into dihydroepiandrosterone, and this is converted to aldosterone, and this is converted into testosterone. So this is about the biosynthesis of the corticosteroids. Next is its biological effects and uses. Let's see what is its biological effects and uses. So they mainly act on the carbohydrate protein metabolism and also promote the glycogen deposition in the liver, and they promote the lipolysis due to glycogen, growth hormone, adrenaline, and thyroxine. So they inhibit intestinal absorption and enhance the renal excretion of the calcium. So next uses. It is used in the certain conditions like acute adrenal insufficiency, chronic adrenal insufficiency, severe allergic conditions, autoimmune disease, asthma, eye diseases, skin diseases. So for this conditions, we are using it for the treatment. Next, let's see what are the mineralocorticoids. So first one is aldosterone. So here 1, 2, 3. So we are seeing here six-membered structure. That is the phenanthrene 1, 2, 3. Three six-membered ring. The structure name is phenanthrene, and here one five-membered ring is there. So that is cyclopentane. So phenanthrene, cyclopentane. Here in the third position, oxygen group is there, and here in the 11th position, hydroxyl group, and here in the 13th position, carboxylate, and in the 17th position, 2 hydroxyacetyl. See here 1, 2. 2 carbon atoms are there. In the second position, hydroxyl group is there. So it is 2 hydroxyacetyl structure is attached in the 17th position. See here 1, 2, 3. Phenanthrene, this is the cyclopentane. In the third position, oxygen. In the 11th position, hydroxyl group. In the 13th position, carboxylate. And here in the 17th position, 2 hydroxyacetyl structure is attached. So this is the structure of the aldosterone. Next, 11-deoxycorticosterone. So here 1, 2, 3. Here this is the phenanthrene structure, and this is a cyclopentane. And here in the third position, oxygen group is attached, and here in 10th and the 13th position, methyl group is there. And in the 17th position, 2 hydroxy 1, 2. In second position, hydroxy group is there. So it is 2 hydroxyacetyl. Next, fluorocortisone acetate. So if you see the structure here 1, 2, 3. 3 6-membered ring, that is phenanthrene, and here cyclopentane. For here in the third position, oxygen group is attached, and here in the 10th and the 13th position, methyl groups are there. 2 methyl. 10th and the 13th position, methyl groups are attached. And here in 11th, see here in the 11th position and in the 17th position, hydroxy group is there. And again in the 17th position, ethyl acetate group is attached. In here in the 9th position, fluorine is attached. So it is the phenanthrene, cyclopentane. In third position, oxygen. In 10th and the 13th position, methyl structure, and in 11th and the 17th position, hydroxy. 9th position here, fluorine, and in 17th position, the ethyl acetate is attached. Next one is the glucocorticoids with moderate to low salt reduction. In this first one is cortisone. Here if you see the structure here, this is the phenanthrene. 3 6-membered ring, that is phenanthrene. Here one 5-membered ring is cyclopentane. In third position and in 11th position oxygen is there. In third and 11th position oxygen. In here in the 9th, sorry, in the 10th and the 13th position the methyl group is there. Here in the 7th position 2-hydroxy acetyl group is attached. See here, this is phenanthrene, cyclopentane in third and the 11th oxygen groups, and here in the 10th and the 13th position methyl, and here in 17th position hydroxy. Here in the second position 2-hydroxy acetyl group is attached. Next, hydroxycortisone. Here this is the phenanthrene's ring. 3 6-membered ring, that is phenanthrene, and this is the cyclopentane. Here in the third position oxygen, and here in the 11th position and 17th position 2-hydroxyl group. See here in the 17th position and here in the 11th position 2-hydroxyl groups are there. Here in the 10th and the 13th position methyl groups are attached. In the 17th position 2-hydroxy acetyl is attached. This is the phenanthrene, cyclopentane. In third position oxygen. In 11th and the 17th position hydroxyl groups. In 11th and the 13th position methyls groups, and here in the 17th position 2-hydroxy acetyl is attached. Next, prednisolone. If you see the structure here, this is the phenanthrene. 1 2 3 phenanthrene, cyclopentane. In the third position oxygen, and here in the 11th and the 17th position hydroxyl, 10th and the 13th position methyl. In the 17th position in the 17th position 2-hydroxy acetyl is attached. This is the phenanthrene, cyclopentane, and third position oxygen group. In 11th and 17th position hydroxy groups are attached, and here in the 10th and the 13th position methyl group is attached. In the 17th position the 2-hydroxy acetyl is attached. Next one, prednisone. If you see the structure here, this is the phenanthrene ring and this is the cyclopentane ring. In the third position and the 11th position oxygen groups are there. In the 10th and the 13th position methyl groups are attached. In the 17th position 2-hydroxy acetyl is attached. See here, phenanthrene, cyclopentane, third position oxygen, and also in 11th position oxygen group is attached. In 10th and the 13th position methyl groups. In 17th position 2-hydroxy acetyl group is attached. Next, beta-methasone. Next name is beta-methasone. So if you see here, this is the phenanthrene and this is the cyclopentane. In third position oxygen group is attached, and in 11th and the 17th position 2-hydroxyl groups are there, and here in 10th, 13th and the 16th position 3 methyl groups are attached, and here in the 17th position 2-hydroxy acetyl group is attached. This is the phenanthrene and this is the cyclopentane structure. In the third position oxygen group is attached. In 11th and the 17th position hydroxyl group is attached. In 10th, 13th and 16th position The methyl groups are attached. In the 17th position, 2-hydroxyacetyl is attached. Next, dexamethasone. If you see the structure here, this is the phenanthrene ring and this is a cyclopentane. In the 3rd position, oxygen, 9th position, fluorine, and again here in the 11th and the 17th position, hydroxyl group is attached. In the 10th and the 13th and the 16th position, methyl groups are attached. In the 17th position, 2-hydroxyacetyl group is attached. See here, this is the phenanthrene ring, cyclopentane ring. In the 3rd position, oxygen, 9th position, fluorine, and here in the 10th position and the 13th and 16th position, methyl groups, and here in 11th and the 17th position, hydroxy, and here in the 17th position, 2-hydroxy acetyl group is attached. Next, methyl prednisolone. This is next name is methyl prednisolone. If you see the structure here, this is the phenanthrene ring and this is the cyclopentane. In the 3rd position, oxygen, 10th, 6th, 10th, and 13th position, methyl groups are attached. In the 11th and 17th position, hydroxyl group. In second, here in 17th position, 2-hydroxyacetyl group is attached. See here, this is the phenanthrene ring. 6 members are the phenanthrene ring, and here this is a 5-member ring, that is cyclopentane. In the 3rd position, oxygen. In 6th, 10th and 13th position, methyl groups. In 11th and the 17th position, hydroxyl groups, and in 17th position, 2-hydroxyacetyl group is attached. Next, ophthalmic glucocorticoids. First one is medrisone. If you see the structure here, this is the phenanthrene ring and this is a cyclopentane structure. So in the 3rd position, oxygen, and in the 11th position, hydroxyl group, and here in 10th and the 13th position, 6th, 10th and 13th position, methyl structure is attached. In 17th position, acetyl group is attached. See here, this is the phenanthrene ring, this is the cyclopentane ring. In 3rd position, oxygen group is attached. Here in the 6th, 10th and 13th position, methyl groups are attached. Here in 11th position, hydroxy, and in 17th position, acetyl group is attached. Next one is fluorometholone. Next one, this is the phenanthrene. 3 6-member rings are the phenanthrene, and this is a cyclopentane. In the 3rd position, oxygen is there. Here in the 11th position and 17th position, hydroxyl group is present. In the 10th and the 13th position, methyl groups are present. In the 17th position, acetyl group is there. See here, in 9th position, fluorine group is there. This is the phenanthrene, cyclopentane. In 9th position, fluorine. In 3rd position, oxygen. In 6th, 9th and 13th position, methyl groups are there. In 11th and the 17th position, hydroxy group. In 17th position, acetate group is present. Next one is letipridonol etabonate. Next one is letipridonol etabonate. So if you see the structure here, this is the phenanthrene ring and this is a cyclopentane. In the 3rd position, oxygen group is attached. In the 11th position, hydroxyl group. In 10th and the 13th position, methyl. In here in the 17th position, ethoxy carbonyl oxy is present. See here, this is ethoxy, this is carbonyl, and this is the oxy. See, two carbon atoms means ethyl. Here one of the oxygen is there, so ethoxy, and this is the carbonyl, and this is the oxy, and here chloro methyl structure is there. This is the phenanthrene. In third position oxygen, in 10th and the 13th position methyl structures are there, and this is the cyclopentane. In 11th position hydroxyl group, in 17th position ethoxy, carbonyl, oxy is there, and this is the chloromethyl is present. Next structure is, if you see the structure, this is the phenanthrene ring, and this is the cyclopentane. In the third position oxygen, in 11th position hydroxyl group, in 10th, 13th, 16th and 17th position 4 methyl groups are there, and here in the 17th position 1, 2, 3 carbon atoms are there, means propane. So this is a propanol is present. See, this is a phenanthrene ring, cyclopentane. In the third position oxygen group is attached, in the 11th position hydroxyl group, in 10th, 13th, 16th and 17th position 4 methyl groups are attached, and here in the 17th position the propanol group is attached. So next one, glucocorticoids used for the treatment of asthma and allergy. So in this first one is flunisolide. So if you see the structure, this is the phenanthrene. 3 6-membered ring structure is the phenanthrene, and this is the cyclopentane structure. In the third position oxygen, in 10th and 13th position the methyl group is attached, in 10th, 13th and in 19th position 4 methyl groups are attached, and here in the 6th position the fluorine group is attached. Here in 11th position the one of the hydroxyl group is attached. In 17th position 2 hydroxy acetyl group is attached. See here, this is the phenanthrene cyclopentane structure. In third position oxygen, and in 10th, 13th and 19th position 4 methyl groups, and here in 6th position fluorine, 11th position hydroxyl group is there, and here in the 17th position 2 hydroxy acetyl group, and here in the 18th and the 20th position 2 oxygen groups are attached. Next one is belcomethasone dipropionate. Name is belcomethasone dipropionate. If you see the structure here, this is a phenanthrene ring and it is a cyclopentane. In the third position, the oxygen group is attached. In 10th, 13th and the 16th position, 3 methyl groups are attached. In the 11th position, hydroxyl group. In the 9th position, chlorine atom is attached. In 17th position, 1, 2, 3 carbon atoms are there with 1 oxygen. So it is propanol, oxy, and again here in the 17th position, here in the second position oxygen is there. So 2 oxy, 1, 2. 2 carbon atoms are there. So it is ethyl. 2 oxy ethyl, and here 1, 2, 3. 3 carbon atoms are there and with oxygen group. So it is propionate. So structure is, this is the phenanthrene ring, this is the cyclopentane. In the third position oxygen group, and in 11th position hydroxide, in 10th, 13th and the 16th position methyl groups, and here in the 9th position chlorine, And in 17th position, 1, 2, 3, 3 carbon atoms with oxygen group. So that is propanol, oxy. And here, second position, oxygen group, 1, 2. 2 carbon atoms are there. So it is ethoxy. And this is propionate. Next one is mechanism of action. Let's see what is the mechanism of action. So here steroids will be penetrated into the cell as the free molecules, and they will bind to the cytosolic corticoid receptors. So it will free, the steroids will be easily penetrate into the cells, and it will be bind to the specific receptor, that is cytosolic corticoid receptor. So this steroid receptor complex then form a homodimer which allows its translocation into the nucleus, where it binds to the glucocorticoid responsive element in the regulatory region of the concerned gene. So this result in the transcription of the mRNA, which is transported to the cytoplasm, where it causes translation of the desired proteins that brings about the final hormone response. So this is the mechanism of action. So what is it? The steroid, it will penetrate into the cell freely, and it will bind to the specific receptor, that is cytosolic corticoid receptor. So where there is the steroid receptor complex has been formed, it will forms a homodimer, and it will allows the translocation into the nucleus, where it binded with the glucocorticoid responsive element in the regulatory region of the gene. So this results in the transcription of the mRNA, which is transported to the cytoplasm, where it causes transplantation of the desired proteins that will bring the final hormone response. Next, pharmacokinetics. So all the natural and synthetic corticosteroids are well absorbed orally. Means if we taken this corticosteroid through the oral route of administration, it has the well absorption, and hydrocortisone is highly bonded to the plasma proteins. So they will get metabolized in the liver and eliminated through the urine. Next, adverse drug reactions. So short-term therapy with small or the moderate doses will not produce any side effects. Means if you use the drug in the low dose or the mediate dose, but if you use the higher dose, what then we require, there are many side effects, which it will affect the gastrointestinal tract, that is acute hemorrhage, gastritis, peptic ulceration, and pancreatitis will occur. This occurs due to the decrease in the production of the PIGI2, which protects the gastric mucosa. Next, on central nervous system, it will produce a psychological disturbances ranging from manic depressive psychosis. However, such reactions will be responsible upon discontinuation of therapy. Next, crushing habitus. So prolonged therapy with glucocorticoids will cause us several effects like round face with relatively thin lips. Next, on cardiovascular and renal system. Cardiovascular means heart, and renal system means which is related to the kidneys. So here what we can see, hypertension is raising of the blood pressure, hyperkalemic alkalosis, edema due to the sodium and the water retention. So here edema occurs due to the sodium and the water retention, means the sodium will be eliminated after the filtration from the body. So in this case what will happen, again it will reabsorb from the urine, the sodium will get reabsorbed from the urine. Next, suppression of the hypothalamo pituitary adrenal axis. So in this case what will happen, sudden reduction in the dose of glucocorticoid can precipitate Withdrawal symptom which is characterized by the fever, nausea, anorexia, weakness, hypertension. So the therapy should be gradually withdrawn to allow the physiological recovery of the normal pituitary and adrenal functions. Next one, hyperglycemia. So, in case of the diabetic state, can be precipitated because of anti-insulin effect of the glucocorticoids. So, this reversible upon discontinuation of this therapy. Next one is osteoporosis. So it is a common adverse drug reaction which particularly involving the vertebrate and other flatty spongy bones. So in this case it will mainly affect the vertebral columns and bones of the human in post-menopausal women. This complication can be fatal.